axially loaded members. So either i-go through lang natin yung basic concepts, then answer some problems. So the first one is about the Saint-Venant's principle. It basically states that as you go further away from the application of the load, the effect of the internal stresses becomes equal for the cross section. So kapag malapit daw sa load, hindi masyadong equal kasi concentrated yung effects dun sa point of application. As you go further along, it will become equal to the average value of stress. So ang repercussion ng principle na ito for ES102, when we deal with stresses, what we're actually analyzing should be sufficiently far from the point of application. So yun po yung repercussion ni Saint-Venant's principle for our analysis. Okay? Then the module on axially loaded members should have told you how to get to this point, basically, the relationship between the deformation delta and then the internal force N in the area property A and then material property E. So kaya po siya integral kasi pwedeng magpalit-palit yung axial force, area, and even material can change. So yung general equation is actually the integral. So kapag pag-function ni x yung any of the three, you have to integrate. Now, if P, E, A are constant, ibig sabihin homogeneous siya and prismatic. So homogeneous means constant material, so constant E. Prismatic means constant cross section, so constant A. May lalabas na natin sa integral such that we get NL over AE. So bakit naging L? Kasi magiging integral ng dx na lang to. From 0 to L. So kaya L na lang siya. Now, the distinction is made here na N yung nilalagay, hindi P, kasi N is the internal force. So always remember when dealing with the deformation, what we want is the internal force, not the external force P. So internal po yan lagi, ha? Now, for multiple sections, kapag nagpapalit-palit, for example, yan. So we have to take the sum of NL over AE. So kapag dito, iba yung cross section dito compared to dito. Iba yung internal force dito sa first length kumpara sa second length. So you have to analyze them separately. So and then just take the sum of the deformation, NL over A. Okay? So what you're actually getting is the relative displacement. So ibig sabihin ng relative displacement. That equation, force times length over area over E, is actually the relative displacement between 2 points on the member. So for example, member AB, so what you're actually getting is either delta B with respect to A or delta A with respect to B. So you learned from ES101 that yung relative means it's delta B minus delta A. So, bakit mahalaga yung relative na yan? Kasi pwede kasing gumagalaw din si A habang gumagalaw si B. So, may displacement at A, may displacement at B. So, what you're getting with this equation right here is just the relative or the relationship between the two. So, hindi mo actually nakukuha yung delta B agad or delta A agad just by this equation. What you're getting is the relative displacement. Now, the sign convention that we follow is that the relative displacement is positive if it is away from the reference point and negative if it is towards the reference point. So, paano nalaman yung reference point yan? So, we know that for this one, the reference is A kasi siya yung nasa baba. So, ibig sabihin, yung positive, ang ginagawa mo, you cut AB and then you look towards A kasi nga A yung iyong reference section. So, yung positive is basically away from A. So, pag ganyan, yung positive delta B respect to A. Now, paano naman kapag B yung positive? So, kapag B, ibig sabihin, dito natin pinutol, tapos, pag ganyan tayo tumingin. Yung positive na to, away, that would be delta A with respect to B. Yun po yung difference, ha? So, kapag yung reference mo si A, kay A ka titingin. Kapag reference mo ay kay B ka titingin. So, yan po yung difference nilang dalawa. May question dito. Isa to sa mga mahalagang concept na displacement eh. So, ang akala kasi lagi, ito equal na kagad dito. So, hindi po ganun ha. Ito ay equal lang sa relative. Okay? Sige. So, may question muna dito bago tayo tumuloy. Question so far? Wala. Sige. So, pwede na tayong tumuloy sa concept of the axial load diagram. So, the axial load diagram basically illustrates the changes in the normal force. So, for example, you have here a bar. So, ang tip ay, when you use a reference point, just stick to it. Kahit saan kayo pumutol, lagi na kayong doon titingin. So, for example, in this problem, if we cut in AB, we look at A. So, siya na yung reference section natin. So, dapat kapag kay BC tayo nag-cut, kay A pa rin tayo titingin para di nakakalito. In theory, you can just change, pero for when you're just beginning with the concepts, it's much easier to use just one reference section. Okay? So, balik tayo kay AB. Pag pinutol natin dyan, ganyan siya. Now, we assume tension or assume positive. So, dapat, i-assume natin internal force pa ganyan. And then, apply equilibrium, we get NAB as positive. So, tama na tension na siya. And then, cut dito kay BC, ganyan na itsura. Then again, assume positive as NBC, and then apply equilibrium. So you get a negative answer so that you know that NBC would be compressive. Now, huwag kayo malilito ha, hindi porkit positive to the right, negative to the left. Ang alam lang natin, positive away from the free body diagram, negative towards the free body diagram. So yun yung lagi nyong tatandaan ha. Now, if we cut KCD, so ganito na yung itsura niya. So si NCD would be this one. So again, apply equilibrium, you get negative 7 kilonewtons. Now, para saan yan? You can now form the axial load diagram for this section. So you have to graph N versus the length. So kay AB, sabi, positive 5. Tapos pagdating kay BC, magiging negative 3 daw. Tapos pagdating kay CD, magiging negative 7. Tapos sasara natin yung diagram. So, yan po yung paggawa ng axial load diagram. Papansinin nyo, hindi siya necessarily equal agad dun sa applied. D8, walang 4, etc. That's because axial load diagram illustrates the internal normal force, not the external force. So, isa pang gamit ni axial load diagram, it tells you which section experiences the most internal force. Kasi baka pag tingnan nyo lang siya ganito, yung external lang, hindi nyo alam alin dyan yung pinakamalaking internal force. Dito ba sa may 8, dito sa may 7. Pero using the diagram, you can now easily tell which section experiences the most axial force. Okay? So that's your axial load diagram. Now, balik tayo sa concept ni relative displacement. What we get from NL over A is the relative displacement of A with respect to D. Now, delta A with respect to D is actually equal to delta A with respect to B plus delta B with respect to C plus delta C with respect to D. Bakit nagkaganon? Kasi ito ay A minus B, ito ay B minus C, kasi ito C minus D. So, papansinin nyo, makakancel itong B, kasi ito makakancel, such that you're left with A minus D, which is the same as this one. Okay? So, kailangan natin isa-isahin ito, tsaka ito. So, delta A with respect to B is the first term. So, we know the internal force in AB is 5. So, L over A in AB. Tapos, kay BC naman, we know that the internal force is negative 3. So, negative 3 yung ginagamit natin. And then, CD is negative 7. So, negative 7 yung nandito sa third term. Okay? So this one, again, it gives you the relative displacement of A with respect to D. So what if D is a fixed support? Now, if D is a fixed support, remember, this is equal to delta A minus delta D. So yan yung delta A with respect to D. So mangyayari, kung fixed support si D, edi ito 0. So such that we get delta A to be equal to delta A with respect to D. Okay? Natindihan po ba? So, nangyayari lang yon kapag 0 yung isa. Pero otherwise, hindi. Now, here's another question. If we get delta A with respect to D as positive, yan, positive siya, saan papunta si delta A? Is it going to the right or going to the left? If delta A with respect to D is positive, saan papunta si delta A? Right or left? Sige po, you can use the chat box to answer. Right ba or left? Kung positive si delta A with respect to D. Ano ang inyong hula? Actually, hindi na dapat siya hula by this point. Ulit ha, delta A with respect to D is positive. So, saan papunta si delta A? To the right or to the left? Right, left. Naku, magkakaiba tayo ng sagot. May nagsagot ng right, may nagsagot ng left. So, paano nalalaman? So, again, what is your reference section? Delta A with respect to D. Ay, taliban. So, our reference section is D. So, your positive must be away from D. So, away from D, ibig sabihin, pakaliwa. Tama ba? So, delta A with respect to D is positive to the left, negative to the right. Paano naman kapag delta D with respect to A? So, paano kung positive pa din? Delta D with respect to A. So, dapat yan, away from A, so to the right na siya. Okay? So, yun po yung ibig sabihin yan. So, you have to check kung ano nangyayari dito sa, kung ano yung reference section nyo, ha? Okay? So, what if you have systems of actually loaded members? So, imagine you have two ropes, A, B, and C, D. This one is a ring, so nakatali po yung A, B, and C, D. So, the first thing you do for systems of members is determine the internal forces using equilibrium. So, you have this. So, meron kang BC and AB. So, para ma-make sure nyo, this is just assumed tension. So, hopefully by now, alam nyo na ganyan yung assumed tension. Yung kapag ito yung joint, away from the joint is tension towards the member. Medyo nakakalito kasi towards the member pero tension. Pero para madali nyo matandaan, so if you have the joint, this is P, ang gawin nyo, mag-iwan kayo ng konti. So you have here BC, tas meron ditong AB. So pag ganyan yung tension, di ba? Tension, tension. Okay? So, by law of action-reaction kasi, ito yung kaputol niya. So, meron pa ganyan. So, ito naman dito. Yan. So, yung tension is always away from the free body diagram. Okay? So, you just use equilibrium equations to find those values. And the next one is you unlock the joint. Ibig sabihin, parang hahayaan mo siyang mag-deform. So, for example, si AB, nalaman natin na tension. So, dapat hahaba siya by this much, delta AB. Tapos si BC, pag nalaman natin na tension, so dapat hahaba siya by this much, delta BC. So, parang wala lang joint B, nag-extend lang sila dahil tension sila. Then, you bring back joint B by visualizing rotation. So, kapag rotation kasi, small strain analysis tayo, di ba? So, kunyari ito, mag-rotate pa ganyan. In theory, this is an arc. Pero dahil small strain relationship, we assume that to be equal to this length, basta perpendicular ito dito. Okay? So, parang ito yung initial na elongation, and then you rotate towards this point. So, drawing lang tayo ng perpendicular line dyan. Same goes for BC. So, drawing tayo ng perpendicular line. Kung saan sila mag-meet, yan yung final position ni B prime. So, yan po yung pag-analyze kapag systems of actually loaded members. Okay? And then you were also taught the concept of indeterminate actually loaded members. Paano naman nagiging indeterminate? So, first is support indeterminacy. So, ibig sabihin, you have more support reactions than you have equilibrium equations. Now, in theory, we have three support reactions kasi fix ito. Pero dahil axial lang yung member, so horizontal lang, ang magagamit mo lang na equation ay isa lang. Yung summation of forces X lang. Kasi hindi yung magagamit yung summation moments Y, summation moments saka summation forces Y. So, meron kang isang unknown dito, yung horizontal. Tapos dito din, may isa din. Yung pa ganyan. So, dalawa yung unknowns mo, pero yung equilibrium equation mo, isa lang. Summation forces X. So, therefore, you have indeterminacy. More unknowns than equations. So, the next kind of indeterminacy is from member indeterminacy. So, pag dinrawing nyo kasi yung free body diagram ni CDE, meron kang force dito and force dito galing sa pin. May force dito galing sa DB, and then may force dito galing kay AC. So, yung unknown mo, 1, 2, 3, 4. Pero yung equilibrium equations na available, tatlo lang. Moments, Fx, Fy. So it is indeterminate due to the additional members. Kung wala itong DB or wala yung AC, determinate na siya. Pero dahil parehong meron, indeterminate na po siya. Then the last kind is material indeterminacy. So yung material indeterminacy naman happens when you have multiple materials carrying the same load. So ang pag-imagine dyan, merong parang plate dito. So kung may plate dyan, tapos in-apply mo yung force, parang yung force ngayon, madidistribute dun sa concrete tsaka dun sa steel, kung yun man yung dalawang members. So merong force na dadali nito, may force na dadali nito. So ang hindi natin alam kung ano yung hatian nitong dalawa, pero dapat yung sum nila, yun pa din, 80 kilonewtons. So the number of unknowns is greater than the available equilibrium equations. That's why we need to use compatibility equations or equations that deal with the geometry itself. So the steps for analyzing is number one, determine the degree and the type of indeterminacy. The degree of indeterminacy tells you how many compatibility equations you need. Kung first degree indeterminate lang, edi one compatibility equation lang kailangan mo. Second degree indeterminate, edi two compatibility equations. Paano nalalaman yung degree? Equilibrium equations, baliktad. Number of unknowns minus equilibrium equations. So for example, itong fix, your number of unknowns is 2, yung dalawang horizontal reactions, and then your equilibrium equation is 1. So therefore, your degree of indeterminacy is 1. Ganun po siya. So dito naman, for example, ang unknowns dyan ay 1, 2, 3, 4. Tapos yung equilibrium equations mo ay 3. So you get first degree indeterminacy. Ganun lang po siya. Kapag ito naman, dalawang materials o dalawang unknown, you only have one equilibrium equation, summation force is y. So still a first degree indeterminate problem. Okay? So yung type naman, type of indeterminacy, kung material, kung support, or kung member, tells you which kind of compatibility equation is applicable. So later on, makita nyo yung compatibility equations na yan. So you treat them as redundant forces. So ibig sabihin, parang ina-apply siya as an unknown. Later on, makita nyo kung anong nangyayari for that one. Or in the modules, nakita nyo na dapat yung concept ng pag-apply ng unknown forces. And then the last one is the appropriate boundary conditions or the compatibility equation. So isa-isahin natin sila. So first, for a support indeterminacy, your compatibility equation is the displacement of D with respect to B or B with respect to D is 0. Actually, ang tama dyan ay delta D is 0 and delta B is 0. Pero what we have is the equation that we have is always about the relative. Pero since 0 naman sila pareho, edi yung relative 0 din. So that's your compatibility equation. Now for member indeterminacy, so again, imagine kunyari rigid si CDE, so pin ito, so magro-rotate lang yan. So may relationship yung displacement nito sa displacement nito. So ganyan yung magiging itsura niya kapag nag-displace. So meron kang delta D, meron kang delta C. So you use geometry to relate them using usually similar triangles to determine this display, yung relationship nila. Yung relationship nila gives you an additional equation. So that's your compatibility equation. And then when you have material indeterminacy, ang nangyayari naman ay since meron ka nga parang imaginary plate dito, tapos nag-apply ka ng force, so yung displacement nung material 2 equals sa displacement ng material 1. So kaya ganyan, delta 1 equals delta 2. So sabay dapat sila bababa or sabay aakyat. And then your equilibrium equation is the force carried by material 1 plus the force carried by material 2 equals the external force P. Okay? So yan po yung pagkakaiba-iba ng compatibility equations depending on the type of indeterminacy. Okay? We now go to thermal effects. So si thermal effects naman, so it's equal to alpha L delta T, where alpha is the thermal expansion coefficient, L is the length, and then delta T is the change in temperature. So ito po siya. So imagine nyo kapag ininit, hahaba siya by an amount delta T. Now, this is the case wherein walang constraint. So you're allowing it to expand. Now, the sign convention is that if it is heated, you go away from A, so hahaba siya. If it is, if you reduce the temperature, if you cool it down, lalapit siya kay reference section. Magko-compress. Now, imagine this to extend by amount delta T. So, it's equal to alpha L delta T. So, the resulting strain epsilon T is just the deformation all over the original length. So, cancel si L, you get alpha delta T. Now, this is a case wherein you don't have stress associated with the strain. Kasi, walang constraint. So, ibig sabihin, nag-elongate lang siya without an applied force. So, this is strain without stress. So, yun yung example niya. Now, that is the case kapag walang constraint. Paano kapag may constraint naman? So, kapag may constraint naman, ang nangyayari, imagine nyo muna siyang walang constraint, and so mag-elongate siya by delta T pag ininit mo siya. And then, dahil dun sa constraint, parang mag-a-apply ngayon siya ng reaction force P para bumalik siya by the same amount, delta P. So, dahil dun sa constraint na yan, yung temperature expansion, alpha L delta T, must be equal to the displacement due to the reaction. So, PL over AE. So, equal dapat sila. We know that P over A is equal to axial stress, sigma. So, you rearrange this one, cancel yung L, you get sigma equals E alpha delta T. This one is stress without strain. Bakit without strain? Kasi imagine niyo, yung initial length niya, ito, tsaka yung final length niya, pareho lang. So, hindi humaba or umiksi yung member. Meron ka ngayong stress pero walang strain. Okay? So, kanina may strain pero walang stress. So, yan yung case na yun. Now, paano naman kapag may gap? So, kapag may gap, what happens is, if you heat this up, this will first expand up to this point hanggang sa tamaan niya yung gap. Tapos, pagkatapos niya tamaan yung gap, kapag tinuloy mo pa yung pag-init, mag-a-apply na ngayon ng force yung support reaction. So, yung delta P mo, so parang imagine nyo pag wala itong harang, yung delta T would reach somewhere here. Delta T. Pero dahil meron kang delta P, yung naging elongation niya lang talaga is itong part na to close this gap. So, the temperature expansion is greater than the axial deformation due to the reaction. So, yung difference na yun is equal to the gap. So, ibig sabihin, you can imagine, yung stress na kakalabasan, sigma, is less than yung kanina na sigma t. Dahil nga, hindi na sila equal. Kanina, zero to dun sa kapag nakadikit. So, dahil sa gap, bumababa yung stress na nade-develop. That's why in real life, what you have for construction of bridges or rail, ganyan, meron kang tinatawag na thermal expansion gap. Naglalagay talaga ng gap dun sa pagka-construct para kung nagkaroon ng sudden changes in temperature, kunyari uminit, or in the temperate countries, nagkaroon ng snow. So, meron ka ngayong thermal expansion and contraction. Yung gap, nililesen niya yung stress. So, kaya nilalagyan ang sinasadya na may konting gap, especially for example, roads, ganyan. Merong gap between the sections. So, yan yung gamit nung gaps na yun. Okay?